Are there times at school where slowing down and thinking about something logically would help?
Yes.
Give an example.
Where I was doing a worksheet and a math worksheet and I had a tough problem, so I just set it down and thought about it. I looked at it a couple times and then once I thought about it, the answer came right in my head, so I thought about how to work it.
Perfect example. Boy, that's a really good application. Okay, you and Mimi, it sounds like, did a little bit of work earlier this week. Probably this page might have been the page you did before. I want you to compare page 1B to page 2. What do you see as the same?
There is a square and a triangle. In both of them, there's a square and a triangle and a triangle.
Okay, what else is the same?
There's a certain amount of the same dots as here, like the same number of dots.
Let's get very specific with that.
Okay.
The same number of dots.
Like, let's say that there are 7, then there would be 7 on here, just saying.
Well, let's prove that. Let's
Okay.
take a look. How many dots make up a square?
4.
4. So as you look at this, and what do we call this box? It has a special name.
A frame.
A frame. Good memory. If you look at this first frame in 1B, how many dots are in this frame?
7.
Take a look again.
Oh wait. 11.
How did you come to that answer?
Because I did 4 plus 4 is 8 plus 3 is 11.
And the first answer was 7. How did you come up with that answer?
4 and 3.
Ah, okay. So it's important to systematically scan or search the whole frame before you give an answer. Okay, so your statement to me was, Sissy, that's my name. Sissy, in this frame, there are the same number of dots that we're going to find in this frame. Would you like to stick with that answer?
No, I'd like to change it.
You would like to change it. Tell me your thinking. Why would you like to change that answer?
Because there's not the same amount of squares and the same amount of triangles in the same model frame.
Beautiful language, very clear sentence. Just projecting, not counting, do you think there are going to be more or less dots on page 2 in each frame than in 1B? Don't count.
I think there will be less.
Defend your answer. Give me logical evidence.
Because there's a less of a shape, like the shape is a less figure, like it doesn't have a big of a space.
Doesn't have as big of a space, and to make the figure, these shapes, specifically let's label it, which shape is less of a shape than a square?
Triangle.
A triangle. A triangle has how many dots? Just 3. So off the top of your head, imagine what's in that model frame on page 2. How many dots do you think there are going to be in each frame?
Well, I would say about 7.
Let's take a look.
Oh, there's different amount of dots.
How many?
There's actually 10. So, and that is less than 11.
It is. And the reason it's less is
Because there's more triangles than more squares.
that was an excellent summative sentence. Do you know what I mean by a
Yes.
summative sentence?
Like a summary.
Yes, very concise language, I like it. Okay, so we've got the same, we've got frames, but we know the difference now is not the number of dots. But if we were to look at the overall organization of these 2 pages.
There is the same amount of number of boxes.
We called them what?
Frames.
We did. And how are these frames arranged?
By 4. 4 as in a square. You could do 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, 4.
Interesting, and we know squares have
4 sides.
Do you see 4?
There's more than 4 in there.
So is it going to be a square?
No.
Aha. Okay, how many are there in the organization?
No. 20.
There are 20, and on this side we have how many?
5.
And across the bottom we
4.
have 4. What do we call something that's arranged in a horizontal plane? We call that
Horizon.
The horizon does. That's where we get the name horizontal from. If we're going across this way, what do we call that?
That is a row.
A row. Very nice. What do you think my next question is going to be?
It's a, I would say it's another row, but that's a row, so.
What plane is this on?
This is the first plane, second plane, third plane, fourth plane, fifth plane.
If this is horizontal plane going across a row.
Vertical.
Vertical, very nice. A vertical plane. Show me vertical with your hand. Okay. Very nice. Good thinking, Keith. Tell me, do we have any instructions here?
No, but we do have a model.
Good language. And based upon the model, we can infer what?
That there will be one square and two triangles.
One square and two triangles. But what are we supposed to do?
We're supposed to connect the dots.
To do what?
To make a square or a triangle.
Any square or any triangle?
A 4-sided square or a 3-sided triangle.
Can a square have more than 4 sides?
No.
So this model means that in each frame has to have exactly what?
One square.
Exactly one square, that's what?
Exactly like the model.
Exactly like the model, and?
The two triangles exactly like the model.
Okay. Now, planning is a really important step to help with that just a moment, let me think. If you were to plan, how are you going to solve these frames?
I'm going to strategize.
You're going to strategize. Let's talk about your strategy. What will you do first?
I will look for the square.
Let's write it on the back of the sheet. Step 2.
I would look for the triangles.
I'm going to underline a word in each of your strategy, each step of your strategy.
Okay.
Look.
Look. What look means to me is to find.
What are you going to be finding?
Finding the square or the triangles.
What part about the square are you going to be looking for?
Almost exactly like the models, like the 4 dots that are in alignment.
4 dots in alignment. Let's talk more about alignment.
Okay.
A square has to have what?
4 sides.
And what about those sides?
They have to be equal.
So put that together in a sentence.
The 4 sides of a square has to be equal.
Have to be equal. Okay. Off you go then.
Okay. I think I found my first square. And then, okay. No.
Did we talk about what looking for the triangle might
Finding.
be? Or finding? Let's talk about the triangles. So sometimes simply writing a strategy might mean we've got to do some more thinking about it before we
Actually do it.
Yeah, I agree. So let's talk about the triangles.
Okay.
What specifically will you look for when trying to
They're almost flat triangles, so they're a little bit littler.
Okay.
More straighter.
So maybe they're not equal sides?
No.
Do you know what that's called when you don't have 3 equal sides?
An equilateral. No. A scaling triangle.
A scaling triangle. Dude, I'm impressed. I'm not sure I know that that's right or not. I'll have to look that up and see. One of the words I was looking for starts with an I.
An isosceles.
Do you know what the difference is between isosceles and scaling?
An isosceles means 2 sides are equal and 1 side is not.
Let's take a look.
These 2 are equal, this side's not. That's by itself.
Okay, so would we call that an isosceles triangle? What's a scaling triangle then?
Scaling means none of the sides are equal.
Very cool. You're not even in geometry yet. I'm impressed. Okay, so when you're looking for these triangles, you're going to be looking specifically for what?
An isosceles triangle.
An isosceles that has 2 equal sides. So let's take a look again. The 2 dots that he connected, and you're welcome to come up and see, he said he's more than comfortable for that, are the 2 dots that bisect the right line on the square that are very close to each other. So that was his first 2 dots that you were connecting. So you're scanning systematically, searching in the frame. You're looking for what specifically with the triangle?
2 sides that are equal and 1 side that is not.
Okay, and those 2 sides that are equal, you showed me. What do you notice?
They make a right angle.
I wonder if that's going to help you in finding them. Why don't you write in the air over the dots that you think get connected?